So now that we've talked about an overview of combining results for Java parallel streams internals, let's take a deeper dive and show how these work and show how they don't work when you run across common traps and pitfalls of using parallel streams. And this can get you in big trouble if you're not really careful in your understanding of how the semantics of collectors work with parallel streams. So just to kind of reiterate what we talked about before, it's very important to understand the subtle semantic differences between collect and reduce. And a good way to keep this in mind, if you don't remember what I'm about to say, is always make sure you test your programs, even if you're intending to do them sequentially, at least at first, test them with a parallel stream, because that will demonstrate very quickly mistakes that you might make. And this is an example that comes from my EX17 folder, and it'll show what can go wrong if you mistake the semantics of the difference between reduce and collect with respect to immutability. So this example is called buggy stream reduce 3, and what it does is very cool. This is a good technique to be aware of. In streams, you can actually conditionally turn on parallelism in a stream dynamically. And let's talk about how you do that. So what happens here is we first create ourselves a local variable called word stream, which is going to take all words is just the list of words in Shakespeare, and we're going to go ahead and make that into a stream. So now we have a stream of words. Now remember that this doesn't actually do anything because streams are lazy. So when you make this call, all it does is just stash away in a local variable the fact that this is a stream, and it knows it's a stream for either an array list or a linked list or whatever. Let's say for sake of argument it's an array list, just to make it easy. It doesn't really matter for the purposes of our discussion. The next thing we do is we take a look at a parameter that's passed here called parallel. And this allows us to dynamically switch the stream into parallel mode. And that's what's cool. That's what I want you to be aware of. So you can conditionally turn on or off parallel processing on a stream by doing a trick like this. You have an if statement, which says if parallel, which is either true or false. And then if it's parallel, we take what was a sequential stream and convert it into a parallel stream. So very easy thing to do. And this is a good way to figure out whether parallel processing is going to give you a win. So rather than sitting down there and trying to compute the n times q model and does it come over 10,000, just write a little piece of code like this and try it out, and then you'll know right away. So let's see what we are going to do next. Oh, another little side note. Always remember that if you have sequential and parallel calls in your stream pipeline, that whichever one occurs last wins. So in this case, we start out with a sequential stream, and then if parallel is set to true, will now be a parallel stream. But if we were to somehow later, before we hit the end of this thing, say word stream dot sequential, which is also a perfectly legal thing to do, that would turn off parallel processing. And it doesn't work by saying, make this piece of the pipeline parallel, make this piece of the pipeline sequential. Whichever one occurs last is the one that wins, because nothing happens until the terminal operation is reached. That's the most important thing to remember. So when parallel is set to false, this code works perfectly fine, and I'll walk through the code in a second. But when it's set to true, then chaos and insanity will ensue. So let's first talk about the happy case. So what we're doing here is we're using a class called string builder. And a string builder is a convenience class designed in Java, and its purpose is to allow you to create a data structure that you can then append elements to efficiently without making copies. Why do you need to do this? Because if you use the plus sign, remember the concatenation of strings operator in Java is the plus sign? If you use the plus sign, then that ends up making a copy. It takes both substrings, or if there's multiple strings that are plus together, it takes all the strings, copies them into a new string. Whereas string builder will append the string at the end of a buffer. So it's inherently mutable, right? It's changing the internal state of string builder. So when this is running with sequential, when parallel is set to false, that's okay. Here's the identity object, which is an empty string builder. And then what we're doing is we're appending to it as we do reduce, so it's appending. However, if we switch to parallel streams, then chaos and insanity will break out because the appending will be done here in multiple threads at the same time. And that's bad because string builder is actually not thread safe. So by design, string builder is intended to be used only either in a single threaded program or where external synchronizers are provided to synchronize the behavior of string builder. Now, you could use string buffer. That would be another option here. We could replace string builder with string buffer. And you could read this article that talks about string builder versus string buffer. String buffer is like string builder, but it's thread safe. String builder is not thread safe. So bad things will happen. So one solution you could use if you don't want to have like surprises when you turn on parallel processing, and one thing you could do is you could simply use classic string concatenation, which you can see looks like this. So here we give a new string, a new empty string is the identity value for reduce, and then we add a plus operation here, and that'll just take the two substrings and create a new string. Works, but the problem is you end up with all this extra overhead. So your program will actually be rather slow, even though it'll be correct. Obviously, it's better to be correct and slow than incorrect and fast, right? So never make the mistake of prematurely optimizing things. There's a great kind of cliche that says premature optimization is the root of all evil in computer science. Probably not entirely true, but it's often true. Another solution, which is really the right way to do this particular type of thing, is to use a collector that's the joining collector. So notice we're moving now from using reduce to using collect. So we've moved back to collect, and we're collecting into a single string, which at first glance may seem a little strange because usually we collect into a collection, right? Usually collect returns a collection like an array list or a map or a hash set or whatnot. But in this case, we're using the joining collector to create a single string, but it does it efficiently. And this is a much better solution. So using the Java 8 string joiner mechanism is the way to go for this kind of stuff if that's what you need to do. You also need to be very, very careful of issues associated with identity and associativity. So there's certain things that you have to be aware of, otherwise your program will do very, very strange things and you'll be perplexed. So let's take a look at an example here. So here's a couple of examples, which again you can find in my EX17 folder. So this example, which is called test difference reduce, does a parallel reduction using the minus sign. So it's using the minus operator. And that will fail horribly. And the reason it'll fail horribly is because unlike addition, which is associative, right? So if you have, A plus B plus C, it doesn't matter whether you do A plus B followed by plus C or A plus B plus C. Either one of those works just fine. Subtraction, as you probably are aware from your 4th or 5th grade math class, is not associative. So, A minus B minus C is different from A minus B minus C. So the way you group things matter. And when you start running things in parallel, keep in mind that stuff may not go in a nice linear fashion. It'll be perhaps different each time because of the inherent and intentional non-determinism of parallel processing. So subtraction is not associative, so you can't do non-associative operations for reduce. So that means divide is out, that means subtract is out, but addition and multiplication are in. And that's pretty subtle, right? If you just look at reduce, it may not be clear at first glance that that's what it does. Another thing to be aware of is be careful about the identity function. You have to make sure you pick, or the identity value. You have to pick an identity value that indeed is the identity for the operation that you're using. So this code here, where we're doing addition, will fail if we don't put in a 0 as the identity value. The identity value of any operation is defined as identity operation value equals the value. So of course, if you take the identity value for addition, which is 0, and add it to any value, you'll get the value back. In contrast, of course, the identity value for multiplication is 1, because if you take 0 and multiply it by any number, you won't get the number, you'll get 0. So it's 1 as opposed to 0. So make sure you pass in the right value for identity. So multiplication behaves differently than addition does with respect to identity. I think everybody here sort of knows this, but it's easy to forget it, and it's easy to get it wrong. And as is often the case, the library doesn't save you from yourself, right? It expects you know what you're doing. So if you pass in the wrong value, you get bizarre results. What is the key thing to remember? unit tests. So if you have unit tests, then you can catch these kinds of bugs. There are many more nice discussions of reduce versus collect that appear in this video by my friend and colleague Angelica Longer, who's an expert on Java and many other things. And so she talks at length about some of these issues. It's like a 3-hour video or something like that. No, I take it back. It's a 45-minute video, and she's got several parts to it. I think there's 2 parts, so it'll go longer than this 7-minute video does, but we cover a lot of the same things, and a lot of the key points are there. Okay, so that's the end of our discussion of combining results. And now you should know kind of some traps and pitfalls, what not to do, and how to do a better job of designing your code to avoid these traps and pitfalls. And crucially, thing to remember is not having, or make sure you have unit tests.